everyone. We will solve the following exercise. The exercise is the number 2.39. Determine the components of a unit vector that is parallel to the hydraulic actuator, BZ, and points from B towards C. All right. This is the first time that I try to, this is my first attempt basically for me to solve this exercise. So we're going to do it together. Now, what we have to make sure is that we have all the information needed for us to determine a unit vector. Remember, guys, for when we're talking about vectors, you have to take into consideration two things, just two. The first one, the magnitude, the second one, the direction. The direction is given by the initial point and the final point. It is not going to have the same direction. For example, in this case, this vector than this other. All right, you have to make sure that you're pulling towards the correct direction. Now, regarding the information that we need for us to determine a unit vector, for example, the unit vector RAB, for example, for a vector called RAB, the unit vector RAB is going to be given by two equations. We can either use the angle, or we can use the most common equation used for us to determine a unit vector, which is the unit vector is going to be equal to the vector divided by the magnitude of the vector. Remember, for when we are talking about magnitude, we are going to talk about a scalar. That means a number, which could be 1, 2, 3, 2.5, whatever, a number. For when we're talking about a vector, we have to take into consideration some different components. That depends. For example, if we're working in 2D, we have to take into consideration the x-axis and the y-axis. In 3D, the z-axis. Now, we have the equation, the principal equation. They are telling me that we need to determine, I mean the book or whatever it has made this exercise, RBC, the unit vector RBC, from points B towards C. Remember what I mentioned before. It is going to be equal to the same equation that we have above it, above what I'm writing at this moment. And it is going to be RBC divided by the magnitude RBC. Now, let me see. All right, so we need BZ. We need this vector. How can we determine that vector? Let me see, we can create, for example, let me put it, I think this is enough. We can create this triangle. All right, because the magnitude of the vector is going to be equal to this magnitude, to this length. All right. So we have this cathedus, which is 0.6 plus 0.15, which is equal to 0.75. And we have the other cathedus, which is 0.6. Now, the magnitude of the vector is going to be equal RBC. Magnitude is going to be equal to the square root of 0.75 square plus 0.6 square. All we have to apply right here is Pythagoras, right? Pythagoras, I think that it's called in English. Let me see, let me solve this part. So the square root of 0.75 square plus 0.6 square is equal to 0.9604. I always use 4 significant digits after the comma. That means 1, 2, 3, 4. Now, this is in meters, right? Because we're working right here, meters, meters, and meters. Meters and meters. This is something that I didn't mention, but you have to make sure that every single one of the lengths that you are using within every equation is in the same unit system. It could be US customary base units or international system units. Now, let me see what else we can do. All right, we have to determine a point zero. The exercise is given to us. Sometimes we have to do it by ourselves. This is the point zero. All right, so we can determine the coordinates of point B and point C, right? Of point B and point C using the coordinate system. Take into account this zero. Now, the coordinates, the 2D coordinates for point B are 0 for x, comma, 0.75 for y. And doing the same thing for the point C, it is going to be equal to 0 for x, and for y is equal to 0.6. Now, I did a mistake right here. Why? Because the first digit is going to provide me the magnitude with respect of the x-axis. That means that this is regarding the x-axis, and as you can see, it is not 0, it is 0.75. So let me correct it. It is basically the other way around. So 0.75, comma 0. Now, the vector, once you have the coordinates, to pull out the information of the vector is pretty simple. You just have to do a subtraction. You are going to subtract the final point minus the initial. So basically, taking that into account, the vector RBC is going to be equal to the final point is C. That means that 0 minus 0.75 along the I direction plus 0.6 minus 0 along the J direction. Once again, you have to make sure that you are working with the correct parameters with respect of the axis. For example, I is directly x, basically. That means that I'm going to use the x digits that I mentioned before. Final minus initial, 0 minus 0.75. And we're going to apply basically the same methodology for the other digit, for the y-axis, directly related with j. Alright? So this is basically RBC is equal to minus 0.75 on the I direction plus 0.6 on the j direction. Alright? We have the vector and the magnitude. Now, what else do we need? This is pretty much it, what we need. There is one way in which you can make sure that the answer is correct. For example, as you can see, this vector is divided, or its components are going to be this one and this one. All right, why is that? Basically because when you add two vectors, this and this, the result is going to be a vector that is solving the projections of the other two. I know that this could be a little bit confusing, but At this point, I have to say that please go to my previous videos when we started working with vectors, and we did a lot of exercises relating the summatory, graphically speaking, the summatory of vectors. But basically, if I want to add, I'm going to do it like this. If I want to add this vector with this other, all I have to do is to create a new generated vector, and the only conditions that I have to meet is that I have to create, or I have to put together these two vectors, tail with head. All right, for example, like this. For example, right, sorry. For example, like this. As you can see, tail with head, and the result is going to be generated between the borders, the corners of the vectors that are at the corner, which in this case are only two, for example. And the result is going to be generated the other way around. Head with head, tail with tail. As you can see right here. For example, if I want to add another vector, for example this one, well, I'm going to meet the requirement, and once again close the shape, tail with tail, head with head, and this is going to be the result. Please, if you didn't understand what I mentioned before, go to my previous videos. I think that I took a lot of time for me to explain this better. Now, what was I doing? Alright. As you can see, this vector is generated by these two. Alright, so this means that the x coordinate has to be negative because it's pointing towards the opposite direction of x, and the y coordinate is positive because it's pointing at the same direction, towards the same direction, sorry. And this is what we have right here, negative, positive, x, y. Now, all we have to do is to solve this equation. So RBC, sorry, the unit vector RBC is going to be equal to minus 0.75 along the I direction plus 0.6 along the J direction divided by an scalar. I do not remember if I mentioned previously, but when you're dividing a vector by a scalar, the result is going to be a vector. All you have to do is like apply the division to all the components, like I'm going to do at this moment. 0.9604, 0.9604. It has to be distributed by all the terms of the vector. RBC, the unit vector RBC, is going to be equal to minus. I'm going to save this number within the calculator, and I'm going to teach you how. I just have to press Shift and this for me to open the storage, and I just have to select which storage, within which storage I want to save the number. For example, I want to save it within the D storage, the E or the F, whatever. For example, D. Now, for when I look for D, I'm going to have the answer, right? That is pretty simple for us to use as many decimal numbers after the point it's possible, as many as possible. Now, minus 0.75 divided by d. And this is equal to minus 0.7808. Sorry, bear with me. On the I direction. Plus the same thing, but 0.6, and it is positive, but it doesn't matter. 0.6246. Yeah, along the J direction. And right here, guys, we have the final answer. There is a way in which we can determine if it's correct or if it's not. As I mentioned before, when you're talking about vectors, you have to take into consideration two things. The first one, the magnitude. The second one, the direction. Remember? Now, for when we're talking about a unit vector, as the name suggests, a unit vector is a vector which magnitude is equal to 1. Alright, so the magnitude of the vector that we just determined, we just calculated, has to be equal to 1. If it's not, there is a mistake somewhere. So 0. I'm not going to use the minus. Okay, I'm going to do it because I think that this is confusing for some students. You have to put the symbol of the number within the parentheses. So basically it's the same thing as not placing the minus. For example, minus 0.7808. If I close this parenthesis and I take that number to the square power, I'm going to have minus 0.7808 times minus 0.7808, which is equal to a positive number. So, as I mentioned before, it is not mandatory for us to place that symbol. 46 square. And as you can see, it is not exactly equal to 1 because I'm missing a lot of decimal numbers after this 8, for example, but it is really close, right? So we can say that it is basically 1. Well, guys, this is all for this exercise. Basically, this is how you can solve this exercise.